Why it is difficult to discover theory of everything? In order to understand this question, let's start from a simple example. First, look at your phone, a teeny device made of atoms. Now, look at the moon in the night sky, a giant rock held in place by gravity. What if I told you that the rules governing the phone in your hand have nothing to do with the rules that govern the moon? For over 100 years, scientists have been searching for a single, simple theory to explain all of it, a theory of everything. But they have failed. Why? Our problem is that we have two beautiful theories. Both work perfectly, but they cannot stand each other. These both theories are general relativity and the quantum mechanics. General relativity, developed by Albert Einstein, it is a theory that explains how gravity works in the universe. Let's break down the key idea of general relativity into 5 places. The first one, space and the time are connected. Imagine the universe as a starchy fabric called space-time. Everything, planet, stars, you, exists on this fabric. Second, gravity is a bend in space-time. Massive objects like the sun or earth bind this space-time fabric like a bowling ball on a trampoline. This binding creates what we feel as gravity. When something like a planet moves near a massive object, it follows the curve in space-time, which makes it orbit or fall. The third idea is mass tells space-time how to curve. The heavier something is, the more it warps space-time. For example, the sun creates a big dent, so planets orbit around it. A small object like a basketball creates a teeny dent, so its effect on space-time is much weaker. The fourth, time can stretch or squeeze. Near a massive object, time moves slower because of the strong space-time curvature. This is called time dilation. Example, clock on GPS satellite tracks slightly faster than clock on Earth because they are farther from Earth's gravity. The fifth, light follows the curve. Even light, which has no mass, bends when it travels through curved space-time. This is why we can see stars behind the sun. During a solar eclipse, the light gets bent by the sun's gravity. So, to understand general relativity, simply look at this image, how Earths bend space and time. Now, time to explain quantum mechanics. Remember, Newton's law of motion. It works at massive or huge level, but doesn't work at atom and particles level, like electron, photon. In this case, quantum mechanics is a different idea that is different from everyday physics. Let's break down in simple way. Particles act like wave according to quantum mechanics. Teeny things like electron or light can behave like particles in a wave. This is called wave-particle duality. For example, light acts like a stream of particles or waves, depending on how you observe it. Second, things are uncertain according to quantum mechanics. In the quantum world, you cannot know everything about a particles at once. Example, if you know exactly where a particle is, you cannot know exactly how fast it is moves, and vice versa. This is called the uncertain principle. The third, probability rules. Instead of saying exactly where a particle is or what it is doing, quantum mechanics uses probabilities. For example, an electron may be probably near an atom, but it is not in one exact spot until you measure it. The fourth idea of quantum mechanics is superposition. Particles can exist in multiple states at once. Imagine a coin spinning in the air. It is not just head or tails, but kind of both until it lands. A particle can be in many places or states at once until you observe it, and then it picks on one state. The fifth idea of quantum mechanics is entanglement. When two particles interact, their state can become linked, even if they are far apart. Changing one particle state instantly affects the other, no matter the distance. It is like having two magic dice that always roll the same number, even across the universe. Now, let's go to war. Imagine the two theories fighting over a single point. In the mind of general relativity, A black hole is perfect smooth point called singularity, where space and time are break. But quantum mechanics says, wait a minute, that is impossible. Nothing can be perfect at a single point. It is reality must be polar, uncertain miss. When we try to force them to work together, the maths explodes. This isn't just a small problem, it is a fundamental conflict. The theory that explains the moon and the phone in your hand are at war. Finding a theory of everything is about finding the ultimate peace, treaty that unifies them both. Search for the theory of everything is a hunt for a single elegant truth that can explain all of the strange and beautiful part of our universe. It is a quest to unify the small and the big, certain and uncertain, the phone in your hand and the moon in the sky. We may not have found the final answer yet, but the journey to finding it is what pushes our understanding of physics to new heights. It is the journey to deepest question about who we are and where we come from. So, what do you think? Will ever find a single theory that can explain it all? Let me know in the comment below.